talking about is velocities, linear and angular velocities. This is going to have some formulas in it. So just like the formulas I gave you earlier, you know, we've had two already, S equals R theta and A equals 1/2 R squared theta. You don't have to memorize these. They will be on a formula sheet that I will give you on your test, so you'll get this formula sheet for the rest of the semester. Every time you do a test, you just have to be able to use them and know what's what. So on here, if you have a point P on a circle of radius R, I have my circle, radius is R, point P is out here. If it moves a distance S on the outside of the circle, so S we know is arc length. So if point P moves this far, you can give me the speed of that point. So that's what the linear velocity is, linear speed, just how fast is that point moving. And to do that, just like any other speed, it's just distance divided by time. So linear velocity, we want the distance on the outside, so your distance is S divided by T. V is linear velocity, S arc length, as before, T is your time. We can also talk about how fast the angle is changing. Now if we had the same setup, we have our radius, we have our point, and it moves, you could give the speed in terms of how fast it's moving on the outside, but you could also give it in terms of how fast the angle is changing. That is angular velocity. So angular velocity, just like any other velocity, distance divided by time. Since we're talking about the angle theta divided by t. This is a Greek letter. This curved W is omega equals theta over t. The key to this, just like every other formula where we've used theta, it has to be radians. If you are not in radian measure, your formula will not work. So omega is angular velocity, v is linear velocity. And there is a third formula we're going to look at to talk about the relationship between the two. The formula we've used before, S equals R theta, right? So if we start with linear velocity, v equals S over t. Then I could change my S to R theta. But the last formula, I just told you that theta over t is omega. So this is where that final formula comes from. The v equals r omega is how to go back and forth between linear and angular velocities. So there is a box here that has your formulas on it. There is an extra one. This one you certainly could use, but I am not ever going to explicitly use that. I'll just use one of the other two. So essentially all the formulas we have right now, the S equals R theta, and A equals 1/2 R squared theta from before, and these three new ones. All of these are on, these 5 formulas are on our formula sheet. To use any of them, theta has to be in radians. Omega also needs to be in radians because it involves an angle. I would like on our problems, before I kind of did this, but I didn't necessarily care if you didn't, I would always write down what formula I was using and what my variables were. I really, really want to encourage you to do that. And that also helps me a lot when I'm grading, if I can see what formula you were plugging things into. So we have options now. Some problems there are multiple ways to do it. So please write down what formula you are using all the time. So here is our first problem. Suppose P is on a circle with radius 15 inches. I like to write down all my stuff as I get it. So my R is 15 inches. And ray OP is rotating with an angular speed. What variable is angular speed? S is arc length in this. Angular speed is like angular velocity. What variable did I use? Omega. Equals pi over 12 radians per second. So please write this stuff down. If you didn't solve anything else, I would give you points for writing down what was given in the problem. So A, find the angle. So I am looking for theta generated by P in 10 seconds. So T is 10 seconds. All right. If you don't know what to do, think about all the formulas we have. I think it can be useful just to have a list of them. Okay, so here are my formulas. I am looking for theta, so I have to have some formula that involves theta. Okay, so there are only 3 formulas that I've given you so far that have a theta in them. You know, S equals R theta. We have R, do we have S? No, so that one's not going to help me. The area, did I mention anything about area here? No, so that's not going to help me. Omega equals theta over T. I have omega and I have T, so that's the formula I want to use. Some people like to keep their units as they're writing the problem. Some people do not, so it's completely up to you. Omega is like pi radians in 12 seconds equals theta over T is 10 seconds. So if I multiply that 10 seconds over, it cancels. The benefit to writing your units in the problem is you see my final answer is in radians. But if it confuses you, you can just use the numbers, but I would like for you to label your final answer. So we get 10 pi over 12, let's just leave that in terms of pi, so that would be 5 pi over 6. Theta is the one thing, radians are the units that you don't necessarily have to write. So you can just write 5 pi over 6, or you can write 5 pi over 6 radians. Either way is correct. Anytime we don't have a unit, remember, we assume it is radians. Okay. So B, find the distance traveled by P along the circle. So distance on the outside of a circle, what variable is that? S. So I'm looking for S. In 10 seconds, so my time is still 10 seconds. So I need a formula with S. Okay, if you look at our formulas, we only have 2 options that involve S. Either S equals R theta or V equals S over T. S equals R theta. Do we have R? Yeah. Do we have theta? Yeah, we found it in part A. So that would be an easy one to use. So I'm just going to do S equals R theta. So I don't know S. My R is 15 inches. Bless you. Theta was 5 pi over 6. Again, you don't have to write the inches in here. We've talked about before that S and R always have the same units, so that's how you would know what unit to put on your final answer. So 15 times 5 over 6, let's not multiply out the pi. So that would give me 25 pi over 2 inches. Okay, part C, find the linear speed in inches per second. What is linear speed? What variable? R is radius. V, linear velocity. velocity, linear speed, means the same thing. Okay, so I need V. So look at your formulas involving V. We can do V equals S over T. Do I have S and T? Yes. Or I can do V equals R omega. Do I have R and omega? Yeah, so you get to pick. Which one do you want to use?
S over T.
S over T, okay. So my S was 25 pi over 2 inches. My T was 10 seconds. So just do, if you're using a calculator, do 25 over 2 divided by 10. And you get 5 pi over 4. Our units are inches per second. The S was in inches, the time was in seconds. Any questions right there? So you just have to pick a formula, and like I said, I just make a list and I look which one do I have the stuff to find, and write down what formula you're using. Next example. So a belt runs a pulley of radius 5 inches. So I could write down right now, R is 5 inches, at 120 revolutions per minute. Okay. Anytime your unit is something per something, when you see that per, it's one of our velocities. It's either linear or angular. Linear is a linear distance, something around the outside of the circle. So it would be like inches, feet, miles, yards, those kinds of things. Something you could measure with a ruler. Angular is talking about the angle. So it will either be degrees, radians, or we could say revolutions, because we know a revolution is all the way around a circle and we can translate that into an angle. So when I see revolutions per minute, that is my angular or linear velocity. Angular. So omega equals 120 revolutions per minute. Okay, part A, find the angular speed, so find omega, in radians per second. We already have omega, but in different units, so I need to change it. So I know omega is 120 revolutions per minute. So if I want to get to radians, revolutions need to cancel, so it goes on the bottom. 1 revolution is all the way around a circle. How many radians is that? What's the angle when you go all the way around a circle, guys?
360.
But we're in radians. 2 pi. So those revolutions are gone. We have minutes, and I want seconds. So my minutes are on the bottom to cancel. They go on the top. We want seconds, and we know there in 1 minute there would be 60 seconds. So 120 times 2 pi divided by 60 gives me 4 pi radians per second. Okay, part B. Find the linear speed. What variable is linear speed? V in inches per second. Okay, I need V. So I can do V equals S over T. Do I have S and T? No. Or I can do V equals R omega. Do I have R and omega? Yes. So that's definitely the route I want to take. the radius was 5 inches. Omega is 4 pi radians per second. Again, you don't have to write the units in here. It just helps when if you struggle with knowing what unit to put on your final answer. Radians are like the extra unit. When I take inches times radians, those radians just disappear. So we get 20 pi inches per second. Your velocities, the v and the omega, will always be in something per something. It's a rate.
What did you say happened to where they had just...
Radians are extra. So if there are no units, it is a radian. If you take a radian times anything else, the radian just disappears. So it's only there when we need it, essentially. Other questions? Okay. Let's keep working them then. Okay. So my computer has frozen. There we go. Alright, a satellite traveling in a circular orbit 1,600 kilometers above the surface of the Earth takes 2 hours to make an orbit. The radius of the Earth is approximately 6,400 kilometers. RA, approximate the linear speed. Linear speed is what? V. In kilometers per hour. Okay, we have to figure out what we have. In the Earth, I told you that the radius of the Earth is 6,400 and our satellite is 1,600 kilometers beyond that. So what have I given you?
Radius.
The radius. What would you do with those two numbers? Add them. So the radius here is 8,000 kilometers. Okay. I've also told you it takes 2 hours to make an orbit. So when my time is 2 hours, an orbit means you went all the way around. So what's your angle?
360.
But we need to be in radians always, so 2 pi. Okay, so linear speed is v. We can do v equals s over t. I have t, I do not have s. Or I can do v equals r omega. I have r, but I don't have omega. So first I'm either going to have to find s or omega. So this is one we're going to have to do 2 problems. Let's find s. S is equal to r theta. So my r is 8,000 kilometers. Theta is 2 pi. S is 16,000 pi kilometers. So now I can do the v equals s over t. So s would be 16,000 pi kilometers. T is 2 hours. So 16,000 divided by 2 is 8,000 pi kilometers per hour. There are multiple ways we could get here. That's why it is so important for you to show me your work on this. Write down what formula you're using. Okay, B, approximate the distance the satellite travels in 4.5 hours. So the distance the satellite travels, the satellite is out here, so the distance it travels is what variable? S. Okay, it's not necessarily the same S from up here, because this S is from when I went all the way around the circle. That was from 2 hours. We are talking about in 4.5 hours. My time is different now. So I need a formula with S. So we could do S equals R theta. We have R. We would have to find out the theta for this scenario. Or we could do V equals S over T. We have V and we have T, so that would probably be the easiest one, because the speed isn't changing. So 8,000 pi equals S over 4.5. So multiply over your 4.5. You're 36,000 pi. Is that right? The units, S and R always have the same units, so that would be kilometers. Wait, is that right? Yeah. Second guess myself. Alright. Look at the next one. Find the angular speed. Angular speed is what variable? That's just the angle. V is linear speed. Omega. The W looking thing. What?
It's similar.
There's only a few options. The minute hand of a clock. So I did not give you very much information here. We know that omega equals theta over t. I didn't tell you what units your final answer had to be in, so there are a couple correct answers here. What you need to do is pick a theta and a t that go together. So let's say we just went all the way around the clock. If you go all the way around, what angle is that? 2 pi. Okay, if you go all the way around, time, we're talking about the minute hand. If the minute hand goes all the way around, how much time has passed?
60 minutes.
60 minutes. So you could say pi over 30, pi is in radians, time is in minutes, and that is correct. There are other correct answers here. You could say if the minute hand goes all the way around, it's been 1 hour. So that would just be 2 pi radians per hour. You could even talk about seconds if you wanted. So if it goes all the way around, it'd be 3,600 seconds. So that's pi over 1,800 radians per second. Okay. You don't need all three, but I'm putting all three just to illustrate how important it is to label your units. Because the answer is very different whether you were talking about hours, minutes, or seconds.
It's supposed to be a heck of a time to grade if there's multiple answers to it.
It takes a little bit longer, yes. That's why I really keep asking you guys to show me your work, write down your formula, label your answers. It helps me a lot. Alright, last example. Find S if R equals 9 yards, omega is 2 pi over 5 radians per second, and t is 12 seconds. So S equals R theta. I have R, but do I have theta? No. The other formula that has S is V equals S over T. I have T, but I don't have V. So we're going to have to start either find theta or find V. I think, what do you want to do? Just want to find theta?
Find V.
V is R omega, so we could do that. So our R is 9 yards. Omega is 2 pi over 5 radians per second. So if you multiply those, that radians would disappear. So it would be 18 pi over 5 yards per second. So there's my V. Then we can do V equals S over T. So V 18 pi over 5 equals S, which we don't know. T is 12 seconds. So multiply over the 12. So our S is 216 pi over 5. Units, S always has the same units as your radius. So yards. Alright. Any more questions there? The assignment, I think I printed on there, 3 through 35, every other odd, 37, 41, 42, and 43. I gave you almost exclusively odd problems because the answer is in the back and I want you to be able to check yourself. That also means if you have an answer with no work, you get no credit for it. I am not actually going to collect this until Friday. However, tomorrow you won't just get a full class period to work on it. I may give you some quiz review stuff, kind of talk about our quiz a little bit. So you want to make sure that you have done part of it at least by tomorrow so you can get your questions answered and then work on the next stuff. Okay? Quick.